protection against fire and smoke. Fire must be prevented from spreading, otherwise everything can be over before the fire appliances arrive. Examples: hotels, offices, schools, hospitals, old people's homes, high-rise buildings, industrial premises, garages and warehouses. Smoke can be seen, but poisonous carbon monoxide is invisible. Wired glass only protects against flames, but combustible material is ignited by radiated heat. Smoke emerges from the paper on the other side of the wired glass. It clouds the view. Smoke and vapors penetrate piercings and flow upwards to displace the air and fill the room. Compartments and piercings should be sealed off as much as possible. Miserliness at critical points shows up under fire conditions. Very many tested and authorized devices help to prevent fire and to protect against smoke and heat in a fire situation. Palisol Fireboard, which is only 2 millimeters thick, is very effective. This is BASF's contribution to this important and extremely difficult field. Palisol, the flexible board. It can be bent when heated. At above 100 degrees centigrade, the water in the board causes it to expand to 6 to 10 times its thickness to form a non-combustible and thermally insulating foam. Here, Palisol is inserted between two sheets of metal in a laboratory press. The jaws are heated to 300 degrees centigrade. The water in the Palisol Fireboard boils and forms pressure. The pressure can be read off the gauge. The silicate swells. The pressure increases. The Palisol foams. An expansion pressure of up to 5 bar is reached. The test shows that foaming is not hindered by the covering material. Under fire conditions, smoke and fire represent a threat. In the test furnace, fuel oil burns without smoke as the ratio of fuel to air is controlled. Standardized conditions for testing the fire resistance of building components. A standard plywood door fitted in front of the test furnace. This is no barrier against fire. Combustion vapors penetrate the adjoining rooms. Fire penetration after 7 minutes. Different doors without Palisol, for example, a solid door made of chipboard. Here again, it doesn't take long for smoke to penetrate between the door and the frame. The veneers have burnt off on the exposed side. Small flames over the carpet. The top top of the door remains intact for 20 minutes. Flame applied at the hinge side. This is the weak spot. The corner above the handle distorts. 5 protective strips for wooden doors consist of Palisol Type 100. Aluminium foil, impact-resistant strip, and, for example, a laminated sheet. A flexible sealer strip is fitted in conventional metal door frames. A Palisol strip in laminated sheet under the carpet. When the door is closed, the sealer strip shuts out noise and also prevents penetration by smoke when a fire is started. The heat penetrates the aluminium foil and enters the Palisol strips. These foam and effectively close off door gaps, both large and small. This system with Palisol functions under differing circumstances. The temperatures in the test furnace are in accordance with international standards. No fire bridging at carpet level. When the pressure inside the furnace is raised, the door remains intact. Fire resistance, more than 40 minutes. In a fire situation, smoke-free escape routes also allow access to attack the fire. In a BASF plant, the control room was separated from the production section by 6 wooden doors which had Palisol fireboard fitted in the leaf and edges. After 10 years of service, during which time the doors were used 2 million times, one door is fire tested. The familiar picture. Smoke gets through at the start as no flexible sealer strip was fitted. Palisol closes gaps at the top and finally the bottom edge. Inside the furnace, the foamed Palisol surface with securing staples. Silicate closes the air gap. Only after 1 hour do flames appear at the corners. 900 degrees temperature gradient between the 2 sides of the door. Fire protection properties have not suffered. The old door provides the same degree of protection as the prototype. The fire resistance can be measured by the Palisol. Edging strip is sufficient for a 30-minute resistant wooden door. For 60 minutes, a sheet should be fitted between chipboards. For 90 minutes resistance, sheets are fitted on both sides and covered by protective layers. Resistance is possible up to 2 hours. The variety of types and ranges is reflected by the increase in the number of authorizations issued. This steel door has been distorted by fire. Doors of old design do not offer adequate protection. An improvement. A Palisol strip in the frame sealed in as protection against water and a sheet metal section fitted over it. The steel pin prevents distortion when heat is applied. Palisol hinders distortion and heat flow. The cotton pad does not ignite. It only burns after 40 minutes. When the test is ended, the door can be opened. The foamed Palisol behind the sheet metal. Large, thin, 90-minute resistant steel doors have Palisol strips in the frame and Palisol sheet fitted between the mineral wool and the outer metal. Roses, aerosol cans, and even apricot brandy remained intact inside lightweight Palisol wood structures subjected to flaming. Palisol slat devices fitted in ceiling piercings. Under fire conditions, a barrier is formed, and this closes off against fire for at least 2 hours. The cartridge functions quickly and reliably. Steam causes the shell to expand. Palisol forms a solid block of foam. A simple system requiring little maintenance. Palisol strip is heated and combined with aluminium foil, after which it is wrapped around the thermoplastic pipe. The pipe is fitted into the wall for fire testing. The heat softens the wrapping and pipe. The constricted Palisol strip expands towards the center and thus restricts the cross-section and reduces penetration by heat. After 10 minutes, the incombustible foam forms an absolute seal, and this is effective for 2 hours. Section of the model before and after testing. The aluminium foil accelerated foaming, thus making the Palisol more effective and economical. Although ceiling piercings are a particularly weak point, Palisol forms an effective fire barrier. Although this material is mainly inorganic, it is amazingly flexible. One of the advantages of Palisol fireboard for industrial use. In the form of strip and other shapes for fire-resistant, lightweight building components. Ideas materialized to modern fire protection features. Palisol developed itself to product status. Of guaranteed quality and now used in increasing quantities in many countries. Palisol Fireboard protects life and property against fire and smoke.
fire-resistant building components are used to prevent the spread of fire and smoke. New ways of achieving this are offered by BASF Palo-Sol Fireboard, patented in most industrial states. The core of Palo-Sol Fireboard is fiberglass, wire mesh, and hydrated sodium silicate. A coating of epoxy rosin protects the board against the atmosphere. BASF Palo-Sol Fireboard is only 1.8 millimeters or 0.08 of an inch thick. It's compact, flexible, and can be molded to shape at temperatures of 60 to 100 degrees Celsius, 150 to 200 degrees Fahrenheit. At temperatures in excess of this, the sodium silicate begins to expand and forms a non-combustible protective layer. The procedure is completed at 250 degrees Celsius, 500 degrees Fahrenheit. An expansion pressure of up to 4 atmospheres is the result. The presence of outer layers of material will not hinder such expansion. The expanded Palo-Sol Fireboard has a fine cellular structure and resists compression. The heat insulation properties are demonstrated by using Bunsen burners to heat a metal plate on the left and a piece of Palo-Sol Fireboard. The paper tube on the metal plate ignites after only a very short time. But the tube on the Palo-Sol Fireboard fails to ignite after 20 minutes of similar treatment. Under fire conditions, the Palo-Sol Fireboard also expands and renders door jambs, ventilation flap edges, or seams in light partition walls smoke tight. This model shows a particularly difficult building component combination: a smoke-tight and glazed fire door in a lightweight partition wall. The wall is constructed from chipboard and Palo-Sol Fireboard. The door frame is oak, and a strip of Palo-Sol combined with aluminum foil has been laid in the rebate to function as a heat conductor and thus accelerate expansion of the board under fire conditions. The wooden edge of the door is clad with Palo-Sol Fireboard. And the composite glazing is secured with strips of wood. The building components are fitted in a portable frame. A profiled rubber molding fitted in the door frame not only improves the sound and heat insulation properties, but also prevents escape of smoke in the initial stages of the fire and before the fireboard can expand. The frame is placed in front of the test furnace and bolted. Thermocouples are positioned to measure the temperature at the non-exposed surfaces of the door, glazing, and partition wall. The oil burners are lit. A view of the fire area. Measurement of the temperature in the test furnace using thermocouples. The T-shaped pipes are part of the pressure measuring system. This is the first phase of the fire test. Temperature is controlled to the standard fire graph of International Standard 834, which corresponds to American Standard ASTM designation E 11969 or British Standard BS 476. After a few minutes, the Palo-Sol Fireboard and the fire protective glazing expand to Radiated heat penetration is effectively retarded also by the glazing. After 10 minutes, the expanded fire protective strips prevent escape of smoke from the fire area. A view of the surface of the building component exposed to the fire. The temperature at the non-exposed surface is less than 100 degrees Celsius, 200 degrees Fahrenheit. 32 minutes elapse before the fire can penetrate at the edge. The door lock and catch still function perfectly. The surface of the glazing exposed to the fire has melted, but the expanded sodium silicate has kept the fire sealed in. The data obtained in standard testing are confirmed in large-scale practical testing. People sit in an area bounded on 3 sides by flame, but are not affected because the Polisol fireboard protects them against fire, heat, and smoke. Polisol fireboard was used in combination with wood to manufacture a cabinet, and this was placed at the center of the fire. The maximum temperature inside the cabinet was only 40 degrees Celsius, 100 degrees Fahrenheit. Polisol fireboard is a heat shield for wood, but it can also be used in the same way in combination with other materials. Good combinability and thinness are but 2 of the particular advantages. A wing of the Technische Überwachungsverein at Essen, Germany. Wall cabinets with Polisol fireboard separate the corridors from the offices. These were fitted in 1969. Similar wall cabinets and partition walls are installed in the press center and administration building of the Olympic Village in Munich. The Post and Telegraph Building in Brussels. 1,200 fire doors of various design, all conforming to Belgian Standard 713-020, which corresponds to international standards. Fire testing was carried out at Ghent University. Glazed doors of 30 minutes fire resistance rating. These doors also satisfy thermal insulation requirements at all points of the non-exposed surface. Double doors which close automatically in the event of a fire. The parking area in the basement is divided by sliding doors which are clad on all surfaces with Polisol fireboard. A self-closing device shuts the doors if a fire breaks out. These are but a few of the very many potential uses for Polisol fireboard, and examples of how this material can be used to give protection against fire and smoke.